In example 4.12, we're asked to use transformations of f, and f is defined as the bird function, and we're supposed to use that to be able to graph g of x. And g of x is also a bird function. So if I was to strip away all the operations that are adders, subtractors, or multipliers, I would end up with x to the 2/3. Looks just like my bird function. So on this one, I actually don't really have to figure that out because I was already told that I was supposed to be using the bird function, but it's good to see the connection with example 4.11. And if you can do that, that means that you can also identify what are the transformations that you need to apply. So number one is going to be a reflection over the x-axis, and number two is going to be the shifts. There's going to be a shift to the left by 3 and also down by 1. So I know that the question doesn't actually state to list these things, but that's going to be the best way for us to understand the progression of making the transformation happen. So for this example, since it's our first time graphing with multiple transformations, I went ahead and provided 3 separate graphs. In a test situation, I would only provide you with one graph, and then you can decide how to best use that one graph. But I want us to really see the separation of the different stages that this picture is going to go through. So on the left-hand side, I want us to graph just the basic parent function, so just the bird function, and we have some nice sample points for that. And I'll label this as F. So for the middle picture, I want to take my bird function and I want to apply the first transformation, which is the reflection over the x-axis. And it looks like this. And this will be more important as you start putting multiple pictures on the same graph, and that is the label. I don't want to misrepresent what I have here, because what I have just drawn is not F anymore. It looks like F, but it's not exactly F because it's been reflected, and it's also not G because G requires us to go through both sets of transformations before we can call something G. So this is sort of an in-between stage. It's not quite G, but it's also not F anymore either. Now the way that this is different is because of, again, that reflection. So I'm just going to call it negative F. So that would represent the reflected version of F. And then for the last stage, let's take the second picture. We don't want to go all the way back to the beginning. Let's take the second picture where we applied that reflection, and let's shift that to the left 3 and down 1. So starting at the origin, shift left 3 and down 1, and then do that with the other points as well, and we should have a pretty nice representation for G, and we can label this as G.